Hi everybody, this is a new project. As you see, this is a blinker project. Okay, there are lots of blinker projects on the internet, but this is driven by a CD40106 chip, which is not very big deal, but as you see, the duty cycle is not 50%. But we heard that the only limitation to this chip is the duty cycle, because it's always 50%. Originally, the circuit is very simple. You can see at the top. So here is the chip. So on the top left pin there is DC positive, 8, 9, 10 volts, okay? And diagonally from this pin is the negative, okay? So here is the negative and it goes to the battery, as you see. There are 14 pins or 14 terminals on this chip. We use only 4, so the positive, negative, and the two opposing legs across from the positive on the other side. So on the extreme left is a capacitor. Now this is a very small capacitor and it is connected to the negative, and is also the second and the first, between the second and the first legs is the variable resistor. Okay, so it varies the frequency of this speaker, but it's always a square wave, 50% duty cycle signal. All right, but if you check this out, it's not 50%. Okay, because there's a little trick I'm gonna show you. I just want to change the I want to reverse this duty cycle. I need to put, okay, I changed around the configuration, and now you see a reverse duty cycle. It's on for 20% or 30% and off for 70%. Okay, now it's a 30-70 duty cycle, not 50-50. Okay, so but I'm going to point out the major difference in this configuration here. So originally there was only one resistor or a variable resistor here, but here on this I split the resistors, okay, from the second leg to the first leg on this side. So here is a variable resistor with a diode, okay, pointing this way, and here's another variable resistor with a diode pointing backwards. Okay, so the difference between the values of these resistors or variable resistors is the actual duty cycle. Okay, so if there is 30-70 variation, then it will be 30-70 on the duty cycle. Okay, so that's the big innovation here. And from the second pin I also drive a LED. I put a 3K or different 1, 2, 3 or even 10K resistor, and it's blinking. And here is the negative. Okay, and if you want to drive any other circuit, it also comes from the second leg. It's not the original numbering. I don't know which is first, 1, 2, 3. I don't know which is which. Okay, but the important thing is this dent. Okay, this indenture here, and this should always look to the left. Okay, so it's positioned to the left, and here is a DC in, it is DC out, and these two legs, okay, determine the workings of this chip. And it is not only 50% anymore, because it was a big limitation to it. Okay, so let's check out if it's still running. Yeah, still running. All right. Yeah, sorry, it's a little bit messy, but okay, this is just a prototyping board version. Okay, so you can build yourself a square wave, function generator, and you can change the duty cycle with this very reliable and cheap microprocessor or microcontroller. Goodbye and peace, everybody.